Quantum. Honestly, G4.
Yes.
Are you there? పిలిచిన గంట
Sir.
కనుకోవా లీడ్ కంపెన్సేటర్ అడిగాను కదా మళ్ళీ ఎస్ఆర్ అంటే which one is nearer to origin, pole or zero? Lead compensator. Divya.
Sir.
In which not question?
0, sir.
What about its phase angles? What it looks like. Let's respond anyone. Complete up to here. Phase angle. Yes, ma'am. Is my issue clear now?
Sir.
Yes, okay. So up to here completed yesterday, right? In the last class. Sir, no.
Yes, sir.
Yeah. This is the nonsense. So next, not done. Lag lead compensator. Nice. ఇలాంటి వాళ్ళు మారుతారు మాట్లాడతారు అనుకోవడం ఆ కర్మ. Lag lead compensator. Next one, put a heading. First, the lag lead compensators are used to get very quick response and for good static accuracy. Mainly to get the response as simple as that, as much as possible, as fast as possible, and accuracy is the most important thing here. Accuracy. So here it is saying that lag lead. Lag in the sense which one is nearer? Pole is nearer, or zero is nearer. So lag means this is lag network, and apart from that, this is lead network. So lag lead 1 by beta t. This 1 by t2, and this is minus 1 by alpha t2. So this is pole zero plot of lag lead compensator. Pole zero plot of lag lead. So that's it. Write down all these things. Explain representation of lag lead compensator. So here the S-plane representation of lag lead is shown figure, and it has one real pole and one real zero. With pole right of the zero means lag network, and lead section also having one real pole and one real zero, but zero is right to the pole. So clearly mention those. Whatever the graph we represented there, just note down those points only here. So if you go through this general form, that is JC of S, it is S plus 1 by T by S plus 1 by beta T1 into S plus 1 by T2 by 1 S plus 1 by alpha T2. So where beta is greater than 1 no? And alpha is lies between 0 to 1. Okay, this is the basic network now for lag lead. So apply voltage division rule here also, then you will get that. Derivation C is going to be happening here. So if you see here input side it is these two are parallel, and here it is output side it is series. This network is parallel, and this network is series. Series means addition, parallel means you can go the formula A into B by A plus B like that. Okay. You know down up to here. After completion, tell me. Completed. Hello guys. Completed out. Yes or no? ఎవరికి
Complete.
వినిపించట్లేదా?
Completed, sir.
Next, rising voltage using rule. Input is multiplied by output voltage across that element. So output voltage మనం find out చేసే దగ్గర ఆ elements ఏవైతే ఉన్నాయో I have to take those. That means those two are in series now. If you see this, see here, these two are in series. That way R2 plus 1 by SC. R2 plus 1 by SC. So let me wait. So try to put here it is 1 by SC1. Capacitor 1 and here it is 1 by SC2. Capacitor 1 and capacitor 2 only. Okay. This network is series. And this network is parallel. That is most important. Okay, SC1 and SC2. So if you go through like this, so denominator is equivalent resistance. Equivalent means both all. So first network is parallel and second network is series. So parallel and series. Now do the some analysis here. If you take LCMs and all those things in the numerator and denominator, then it will be like so A of S into R2 SC2 plus 1 divided by SC2. Right? What about in the denominator? A parallel with B. That means A into B by A plus B. Plus, if we take again this same here, that means LCM. R2 SC2 plus 1 by SC2. But implies in the denominator. So in the numerator, plus 1 SC2. And if you take LCM here, this denominator and this denominator will get cancelled. Directly I am writing that one. R1 by R1 SC1 plus 1 plus R2 SC2 plus 1 by SC2. So that implies again take LCM here. So in the denominator take LCM now. SC2 whole divided by, if you take LCM there, SC2 into 1 plus R1 C1 isn't it? That becomes, what will happen? R1 SC2 plus what left there R2 SC2 plus 1 into this term R1 SC1 plus 1. So this is the thing here. After that, if we got A naught by ES, that means output by input, which is equals to, is there any cancellations? Yes. This and this will get cancelled. So if this take to upside, that it becomes S R1 C1 plus 1. This is denominator term actually. And the numerator term actually has this S R2 C2 plus 1 whole divided by S R1 C2 S1 C2 plus those two terms, product of those two terms, SR1 C1, SR2 C2. So now this becomes same thing, common some constant terms and put it in the form of S plus Z by S plus P. Okay, put in the form of S plus Z by S plus C. So that becomes, take R1 C1 in the first element. So S plus 1 by R1 C1. Take R1 C1 in the first element. And similarly here R2 C2. Like that. So R2 C2. S plus 1 by R2 C2 whole divided by. So denominator will have S R1 C2 plus R1 C1 I am taking common. In the second term R2 C2. That becomes S plus 1 by R1 C1 into S plus 1 by R2 C2. Right? So this is all about this one. So now divide with R1 C1 and R2 C2 by denominator and numerator. So whole function divided with this one. So what will happen? R1 C1 R2 C2. So here R1 C1 R2 C2 are there. This gets cancelled. Okay. In the numerator down. The left part is, what is the left part there? S plus 1 by R1 C1 is there, and the second product term is there. S plus 1 by R2 C2. Okay, all divided by here. If you take R1 C1 R2 C2, so R1 C2 gets cancelled. R2 and C1 remains there. So that is S by R2C1 plus here also total term gaya, so remaining terms are there, right? That is S plus 1 by R1C1 into S plus 1 by R2C2. This is the form like this. And if you want, you can multiply this and then you will get some equation. That is S plus 1 by R1C1 into S plus 1 by R2C2. Just multiply these two terms now, that becomes second order equation, right? Will be like, after doing all those things, S square plus S into, try to multiply this term and then try, multiply these two product terms. This is the S term and remaining constant is 1 by R1C1 R2C1. See here my S into S square. Next S into this one, S into this one, plus this one. So R2C1, R1C1, R2C2. So this is here R1C1, R2C2, R1C1. Next is this is multiplied by this 1 by R1C1, R2C2, and the remaining part 1 by R1, C1, R2C2. Okay. So this is the thing. Okay, completed.
Completed, sir.
Okay. So next, proceed this. A transfer function of likelihood compensator is like this. Already written in the first slide. That means starting off this likelihood. So in the same way, we are going to taking that S plus 1 by t1, S plus 1 by t2, whole by S square plus S into. I'm converting those all constants like this one, beta t1, alpha t2. How this is possible or not? So let's write that one. It is like equation number 1. Assume this is equation number 2 and previous one is equation number 1. Now we will compare these two, equation 1 and 2. That means if you multiply these two, this you will get S square plus S into alpha 1 by alpha t2 and S into these two and 1 by alpha beta t1 t2. Okay, now compare this equation and the previous one, what we got. So on comparing, you will get t1 is R1 t1, R1 c1, and t1 t2 and remaining all. Okay, from this, what is alpha beta? From this, what is alpha beta? What is alpha and beta from this equation? Alpha beta equals to R1 R2 C1 C2 by T1 T2. So now, what is T1 and T2? Substitute those values. So alpha beta equals T1 is nothing but R1 C1 and T2 is nothing but R2 C2, right? Substitute those values here. So these all gets cancelled, these all gets cancelled. That is equals to 1. Right? That is alpha into beta equals to 1. And what about alpha from this? Alpha is?
Minus beta.
Sorry? Minus beta now. 1.
1 by beta.
Okay. 1 by beta. So please compare these two now. So now by using, you can replace here or here with alpha equals to 1 by beta. That means from equation 2, replace alpha equals to 1 by beta. So that implies E naught of S by EA of S equals to, what is that? ECE of S, that is compensator open loop function. S plus 1 by T1 is multiplied with S plus 1 by T2 whole by S plus 1 by beta T1. And what about second one? See this. What about this happens? What if alpha equals to 1 by beta? What is there? S plus?
Beta by T2.
Very good. Beta by T2. Because alpha is 1 by beta. So it goes to numerator. Beta by T2. This is what the representation. So if you want to convert into beta, you can like this. If you want to convert into alpha, you can like that. You can change in terms of alpha. That means beta equals to 1 by alpha. You can go like this or like this. Either way. Okay. So where beta is always greater than 1. Always greater than 1. Suppose if you consider alpha, what about alpha range? Is less than 1 or greater than 1? And T1 equals to R1 C1 and T2 equals to R2 C2. And what about this relation? Here also change alpha to 1 by beta. So that implies 1 by R1 C1 plus 1 by R2 C2 plus 1 by R2 C1 equals to 1 by beta T1 plus beta by T2. So replace here also. Because every limits will be changed. All the limits will be changed. So this is all about the lag lead compensator electrical network. It's not complete now.
Completed.
Okay. So write down next frequency response. No? Frequency response. That means S to JW you have to take. Lag lead compensator. Frequency response of lag lead compensator. So take the transfer function and convert that into S1 plus S2 form, that is standard form. Standard form lo convert chesam. And after that put S is replaced by JW. After that S is replaced by JW. Okay. That is alpha beta into 1 plus JWT1 and 1 plus JWT2 or by 1 plus JW beta 1, sorry, JW beta T1 and the second term 1 plus JW alpha T2. Okay. So you already know that for lag lead alpha beta is 1, isn't it? Alpha beta equals to provides a DC gain of unity. That means alpha beta is 1. So replace that one. 1 into 1 plus JWT1, 1 plus JWT2, whole by 1 plus JW beta T1 and 1 plus JW alpha TP. So how many Carnot frequencies here, ma? In this equation? How many Carnot frequencies are there? Innone frequencies. So 4 Carnot frequencies are there. So those are WC1, C2, WC3, WC4. And where the limits is, that means range of those frequencies are WC1 less than WC2, less than WC3, and less than WC4. So now write those Carnot frequencies coming from denominator. Yes, complete grammar. Just one single plot is there. We'll draw the plot. Bhanu completed.
1 minute. Completed.
Remaining guys, respond anyone. Response లేకుండా చెప్పడం నాకు ఇష్టం ఉండదు. తను కావట్లేదో తెలియదు. ఏదో నాకే రాసుకొస్తున్నారు. So let me draw the border plot of the cone. W logarithm scale always. 0 degrees is minus 45 plus 40. So 0 dB line is here. So it is a negative dB. So here the up to W given it is 0. And after that it is decreasing with negative slope. So this is all about lag network. And this is the lead network. Constant and then increasing again. Like this. So up to here lag and then lead. Okay, this is 0 dB. And this is minus 20 dB. So here it is again 0. So here it is again plus dB. Right? So if you go through the phase, if you draw the phase, it will be like it's starting from 0, decreasing up to somewhere else, increasing like anything. So this is the phase. What a plot of lag lead. So here it is phase, and here it is magnitude. So here is phase 1, this is magnitude plot, and here downwards is phase plot. Completed.
Completed, sir.
So in next class we will see PI, PID, and PID controllers. After that we will move to state space. So maximum in 1 week, that is more than enough. If you want, go through the textbook for more number of problems. I'm not going to share as many as possible. If there is a time, I will repeat the first 3 minutes now. Better for you. Madam, you can stop recording. C9.